Let's actually finish up this question by showing that these prices for the iPhone 7, the iPhone 7 Plus are actually a maximum. So we're going to do that by calculating the second derivatives. So if we go up here, here are the first derivatives of the profit. If we take the derivative of px with respect to x, we get the second derivative of p with respect to x, and that's equal to -6. The derivative of px and then y, so take the derivative of px with respect to y, we get 3. And if we take the derivative of py with respect to y again, we get pyy, and that is -2. So with these second derivatives, we're able to calculate the function d at the point x equals 650 and y equals 1350. So at x is equal to 650 and y is equal to 1350, let's see what d is equal to. D is equal to the second derivative of, actually that's, so let's change this to a p. Let's see if I can, pxx at 650, 1350 times pyy at the point 650, 1350 minus pxy at the point 650, 1350 squared. Okay, so let's figure out what the second derivative of p with respect to x is when you evaluate at 650 and 1350. What we notice is the second derivative of all of these things are actually just constants. They don't depend on the point at all. So pxx is -6 and pyy is -2. So we get -6 times -2 minus, what is pxy? Pxy is equal to 3. So this becomes 3 squared minus 3 squared. And this ends up being 12 minus 9, which is 3. So d in this case is positive. And if we look closely, we notice that pxx is negative. So because we have a positive d and a negative second derivative with respect to x, therefore we classify this point. This is a local or a relative max. So indeed, setting the prices to be iPhone 7 to be 650 and iPhone 7 Plus to be 1350, we indeed maximize the profit.